This is really about harness engineering for AI and LLM work, becoming the person who makes these systems reliable in the real world. It's not enough to build something that looks great in a demo. Companies need engineers who can test behavior, catch failures, measure quality, and make models safe and repeatable to ship. That's the role we're talking about here, turning impressive prototypes into dependable products. Harness engineering is everything around the model that makes AI systems usable and reliable in practice. It includes the delivery harness for building, testing, deploying, approvals, and environment management, the evaluation harness for datasets, scoring, tracing, regression checks, and monitoring, and the platform engineering underneath, like infrastructure, pipelines, developer portals, and infrastructure as code. Together, this layer helps turn stochastic model behavior into measurable, dependable quality. Traditional software is usually deterministic. The same input gives you the same output, so pass-fail unit tests work well. AI systems, especially LLMs, behave differently. The same prompt can produce different but still valid responses, because variability is built in by design. That means traditional testing alone isn't enough. Instead, we need evaluations that measure quality, consistency, and performance across many examples, not just whether one exact answer matches. This is the core evaluation loop behind reliable LLM systems. First, define the objective so success is clear, then build a representative dataset. Choose metrics that reflect real performance, and run evaluations consistently. That cycle helps teams catch regressions, compare changes, and improve with confidence. It's the production standard approach, and it's the same pattern endorsed by OpenAI, Langsmith, and Weights and Biases Weave. This slide shows the full harness architecture from code change to production. It starts when a version control update triggers the CI pipeline, where the system builds, tests, and runs evaluation gates. If those checks pass, it moves to an approval gate for human review and quality validation. From there, CD handles environment promotion and deployment, and once in production, monitoring tracks traces and detects drift over time. Here's the role landscape we're seeing emerge. Platform engineers provide the foundation with infrastructure as code, CI, CD, developer portals, and internal tooling. AI engineers focus on eval pipelines, tracing, prompt iteration, and monitoring. AI product teams define quality gates, datasets, human review, and release criteria. And agent engineers go deeper on multi-step observability, policy evaluations, and failure analysis for more complex autonomous systems. In this chapter, we focus on 5 practical skills to build. First, CI/CD fundamentals like pipelines, triggers, approvals, artifact flow, and environment promotion. Second, infrastructure as code for automated provisioning and reproducible builds. Third, designing LLM evaluations with typical edge and adversarial cases, plus human labeling. Fourth, tracing and observability using tools like Langsmith, Weave, and OpenTelemetry. And finally, bringing evals into CI workflows through PyTest or Vitest so teams can rely on them. In Chapter 2, we'll look at the platform tooling that helps teams build and ship reliable AI systems. Harness CI/CD gives you unified pipelines, visual controls, approval gates, and ephemeral environments for safer, faster delivery across modules. Langsmith adds evaluation and trace inspection with both offline and online testing, plus RAG-focused metrics. And Weights and Biases Weave brings tracing, datasets, and evaluators in Python and TypeScript for strong LLM observability. This slide shows the core data flow in a RAG system. A user starts with a query, and the retriever searches for the most relevant chunks of information. Those retrieved chunks are then passed into the LLM generator, which uses that context to produce the final answer. This is the same workflow used in Langsmith's RAG tutorial, and it's a solid pattern to understand for building practical portfolio projects. Chapter 3 looks at why observability gets much harder once you move from a single prompt to an agent. With a single prompt, you have one input and one output, so evaluation is usually a straightforward pass or fail. But multi-step agents make branching decisions, call tools, and update state, so small mistakes can compound. That means you need step-level traces, dynamic quality metrics, and policy compliance checks, not just simple error rates. This project is a RAG assistant built with an evaluation loop from end to end. It starts with a dataset that includes typical edge and adversarial cases. Then I measure retrieval quality, score answers for relevance and accuracy, and use those checks in CI to block deployments when performance drops. Finally, I inspect traces to debug failures visually. So this isn't just a chatbot demo. It's a system with measurable quality gates at every stage. For this second portfolio project, the goal is to build an agent workflow with real observability. You'll instrument a multi-step flow, capture full traces for every run, and then evaluate outcomes with task success and policy compliance checks. What this proves is that you can catch regressions from prompt or model changes before they hit production. For tooling, use Langsmith for tracing and evaluations, and Harness or GitHub Actions as a CI gate. This project is an internal developer productivity tool built around semantic search, workflow orchestration, and evaluation. It lets developers search across documentation, service metadata, and catalog data in one place, then trigger automated actions across different modules. On top of that, an eval layer measures both answer usefulness and whether actions actually succeed. It's inspired by Harness IDP, and it shows platform-level AI thinking, not just calling a model. Chapter 4 focuses on what strong portfolio signals actually look like. We start with dataset design, showing how the data is curated across typical edge and adversarial cases. Then we define a scoring rubric with clear metrics, thresholds, and version-to-version comparisons. We also explain where human review fits in, especially when labeling needs judgment. Finally, trace debugging helps surface the root causes behind failures so improvements are targeted, not guesswork. Here are the key interview questions to be ready for around evaluating LLM systems. You may be asked how to test a RAG system before launch, how to catch regressions after a prompt change, which metrics matter offline versus online, and how evaluation ties into deployment decisions. A strong way to answer is this sequence. Define the objective, build the right datasets, choose metrics, compare versions, inspect traces, and then monitor continuously in production. Your background shapes how you should position yourself in AI. If you come from software engineering, lead with CI/CD, testing, and observability, then add LLM evaluation and tracing. If you're from data or ML, emphasize production maturity like deployment workflows, regression control, and developer tooling. And if you're product-focused, learn the eval and delivery stack so you can speak credibly about release criteria and operational risk. The goal is to be known for making AI systems dependable. This slide compares offline and online evaluation. Offline eval happens before deployment, usually in CI, using curated datasets to measure things like accuracy, relevance, and retrieval quality. Teams often use tools like Langsmith, Weave, and PyTest, along with human labeling and adversarial test cases. Online eval happens in production on live traffic, where we watch for drift, latency, and failures using observability tools, plus spot checks and escalation-based human review. Here's the positioning that gets attention in interviews. Don't frame yourself as someone who just calls LLM APIs and writes prompts. Instead, position yourself as the person who builds the system around AI behavior, the pipelines, datasets, evaluators, traces, and monitoring that make AI features reliable. That tells employers you're not just experimenting with models, you're helping teams ship production AI with confidence. Here's the big takeaway. Harness is the reliability layer that makes delivery and evaluation pipelines work together. In this world, evals are the new tests. They rely on datasets, scorers, and CI gates, not just simple pass-fail checks. Tracing is essential, especially for agents, because multi-step visibility is what lets you debug and trust behavior. And ultimately, don't just show the model, show the harness behind it. What matters now is building the harness around the model. The real value comes from turning uncertain behavior into an engineered system with measurable quality. That's the skill the market rewards, and that's the opportunity in front of us. So the job is clear. Ship safely, test rigorously, and monitor continuously. That's how we make these systems reliable enough to use in the real world.